For Project 3, I wanted to do my question on impulse. So we can read the question first and then we can get started. So the question states, it's the bottom of the ninth in Game 7 of a playoff game between the Red Sox and the Yankees. The Red Sox need one more point on the board to break the tie to send them to the World Series, and the bases are loaded. The Yankees pitcher throws a 0.15 kilogram baseball horizontally at 40 meters per second. The Red Sox batter hits the ball straight back toward the pitcher at 30 meters per second. So with that, we can already write down a couple knowns. So the mass of the baseball is 0.15 kilograms. The initial velocity is 40 meters per second. And the final velocity is 30 meters per second. We also know that since they're hitting the baseball back in the opposite direction, one of them will be positive, so the initial velocity will be positive, and the final velocity will be negative. Write it just like that. All right, so starting with part A, the question states, calculate the impulse delivered to the ball by the bat. So with this, we want to find impulse. So that's J. And impulse, we know, is equal to the change in momentum. So that'll be the change in P. So it'll look just like that. And we know that momentum equals mass times velocity. So we can go here and say J equals mass times the change in velocity. So from that, then we can go into finding the change in velocity. So that's obviously, we're going to do V minus V naught. So it'll be J equals mass times the velocity minus the initial velocity. So look just like this. So then we can go ahead and we can plug the numbers in. So J equals 0.15 times 30 minus 40, or negative 30 minus 40. So that will give you J equals 0.15 times negative 70, just like that. And ultimately, when you do the math all the way, it'll equal J equals negative 10.5 newtons times seconds. So that's the impulse. And then moving on to part B, the question asks, if the bat is in contact with the ball for 0.004 seconds, determine the average force exerted on the ball. So we now know the time equals 0.004 seconds. And for that equation, the average force, so F average equals the impulse divided by the change in time. So just like that. And since we already have both of those numbers, we can go ahead and plug it in. So the average force equals the impulse, which we just found, which is negative 10.5 over the change in time, which was 0.004. So then once you do the math all the way, the average force will equal negative 2,625 newtons. Just like that. So then with that, we can then move on to part C. So part C states, assuming that the ball experiences the same magnitude of force but in the opposite direction, Determine the average force exerted by the ball on the bat and explain the reasoning using Newton's laws. So Newton's third law, it actually states that for every action, there's an equal and opposite reaction in both magnitude and direction. So we know that through Newton's third law, the bat on the ball force equals negative force of the ball on the bat. So it looked like that. And then from there, since we know that the force of the bat on the ball since we found that average force, which is equal to negative 2,625 newtons, that the force of the ball on the bat would equal the same thing. So we can say, therefore, the force of the ball on the bat equals 2,625 newtons. And that's the rest of the question.